Failed prints, prototypes, or just purging poop from multicolor prints? Yes, this is all waste from 3D printing. Instead of throwing this plastic away and paying for new filament, wouldn't it be great to recycle this waste and make new filament from it? I recently bought a DIY filament extruder kit costing only around 600 bucks to find out how it compares to professional solutions that I used in the past that cost at least 10 times as much. Let's find out more. Guten Tag everybody, I'm Stefan and welcome to CNC Kitchen. This video is sponsored by KiwiCo. Get 50% off your first month by using the link below. Everyone who has a 3D printer will collect significant amount of waste over the time, and at least for me it always feels wasteful to throw this into the trash, and I think I'm not the only one here. Over the last years I've already shown several attempts of how to recycle this waste into new filament. Yet so far my machines have either been quite hard to set up and get working reliably, or were so expensive that only businesses can really afford them. But this time it might be different. A couple of months ago, I stumbled over a German company called Artme that make a DIY filament extruder kit that looked really promising. One big downside of other DIY solutions is that they often use a big wood drill or auger as a feeding screw for the material, which kind of works but is far from optimal. Artme use a custom machine feeding screw which doesn't only look really pretty, but should also significantly help to feed and extrude especially threaded 3D prints. And the best thing is that the Artme3D Mark II is, besides some small limitations, basically open source, with the intention of making the machine widely and easily available. You could even build one from scratch and just buy essential custom components like the screw. I ordered a complete kit, and after it had been sitting in my studio for a while, I finally found the time to build and test it out. And just to make it clear, I'm not affiliated with Artme and purchased this machine from my own money. If you appreciate that, please consider leaving a like. Let's look at the basics of such a machine. Very simply spoken, such a plastic extruder is a screw that's driven by a high torque motor that runs inside a heated barrel. The plastic is fed from one end, then gets molten and mixed and leaves the barrel through a nozzle on the other end, producing filament. The Artme3D Mark II is an extruder kit, which means that you get the individual components but have to assemble and wire everything yourself. It also doesn't come with the plastic parts, so you have to print them yourself, and this is what I did at first. I separated the parts into 3 categories. The first one was general parts that didn't have any significant thermal loading, and that I printed from PLA in just 3 fully loaded jobs on my Bambu Lab X1 Carbon. In separate jobs I printed the aesthetic housing parts facing down on the textured PI sheet of my A1 Mini to get a really nice surface finish. The last set of parts are the ones that get a little bit warmer and that I printed from black PETG. All in all, it took me around 50 hours to print all of the pieces using 1.5 spools of filament. Once I was finished with the printing process, I could finally start assembling the extruder. David, who is the designer of the Artme3D, seriously includes everything in the kit, starting from well-sorted screws to tools, and even includes things like super glue and aluminum foil that we'll need in a bit. The only thing that's missing due to legal reasons is the 24-volt power supply, which is another 20 bucks on Amazon. The manual is available in many different languages, some probably machine translated from German. I checked the German and the English ones, which were super detailed, very easy to follow, and reminded me a lot of the manuals from a Prusa printer kit, only without the gummy bears. The assembly process is broken down into several sections, starting with the extruder. Here I fixed the barrel to the pre-cut aluminum extrusion and connected the big and geared down stepper motor to the extruder screw. The ingenious thing here is that the coupler already includes a stir bar that should later help us to evenly feed the very sharp and chunky shredded plastic that otherwise interlocks and even stops feeding. After that, the hopper is added, and the heating unit, which looks like a huge 3D printed heater block, gets fixed to the extruder barrel. The whole assembly gets then screwed to the base. Most of the electronics that are used sit in the back and are simply repurposed from a 3D printer. The wires are all pre-crimped with ferrules, and all the connections are explained seriously idiot-proof in the manual. The extruder motor uses a separate driver module because it requires more power than a regular 3D printer motor. The screen that sits on the side of the machine is also just a really old model I've already been using like 8 years ago on my first printer, but it should be more than sufficient for what we need it for. Next, I assembled the filament winder, which will later spool our freshly extruded material. This is a really clever construction with an adjustable filament guide that automatically reverses its direction once it reaches the stop in order to get a nice and equal distribution of filament over the width of the spool. The spool itself is driven by a separate stepper motor that's connected via a belt that can slip so that the filament is always wound with a perfect tension. Every rotation of the spool, a mechanism actuates the filament guide so that it advances a tiny bit. The next step was a bit messy. In order to stabilize temperatures and reduce the power usage of the machine, the whole extruder barrel gets insulated with some rock wool. I made sure to wear gloves and a respirator, but the fibers still ended up almost everywhere. I wrapped the sheet of insulation around the barrel and then slid the cover over it. The following step was honestly one of the most satisfying ones and shows how much thought David put into his DIY filament extruder. If you've seen any of my last videos on filament recycling, you know that any dirt or metal chips that are in the ground up plastic will end up in the filament. And if they are too big, they will clog the small nozzle. In order to reduce that risk, the Artme3D uses a melt filter, which is a wire mesh that has holes smaller than the typical nozzle diameter of a 3D printer, so everything bigger should be caught here. The mesh is not just put flat in the nozzle, but David's developed a two-stage forming die to create a three-dimensional filter structure for increased surface area and rigidity. After this really satisfying forming process, I put the filter into the nozzle holder that seals against leaking with some Teflon tape. Unfortunately, this limits the maximum extrusion temperature to 260 degrees Celsius, which should still be enough for most extrusion and recycling projects. I then screwed a regular 3D printer nozzle that's drilled to 1.7 millimeters into the holder through which the filament will later extrude. The nozzle is slightly undersized because the molten plastic will swell up a little after it leaves the small hole due to the pressure inside the extruder. After this step was finished, I built and installed a very simple filament feeder that pushes the newly extruded filament to the winder. It has a small tension arm to get enough pressure on the material to pull it, but hopefully not so much that it squishes the still slightly soft filament. The last essential component of the machine is the sensor unit. This is not a filament diameter sensor, but only a filament position sensor. The Artme3D relies on gravity to basically stretch our extruded filament to the right diameter after it leaves the nozzle. To keep the force consistent, it should always droop down a similar amount. The Artme uses an optical sensor for that, through which a translucent piece with increasing thickness is rotated, which will act as a simple angle sensor. A piece of wire is attached to the rotating part through which we'll later guide our filament. And after a bit of final wiring and cleaning up, the Artme3D Mark II is finally finished. This honestly was a really nice and well documented build, taking me a good day to finish. But let's now see if it also works and produces filament in the quality we need for 3D printing. The extruder is easily capable of making filament from pellets, yet we want to use it to recycle our old and failed prints. So I recently printed a bunch of soldering iron tip cases that we sold for our Black Friday special, yet I ended up with a bit of scrap. Some of the prints failed due to bad bed adhesion, clogged nozzles, or filament that ran out. I think these scraps are a perfect opportunity to recycle into new filament and of course print new cases from. These of course don't directly feed in the extruder, so the first thing we need to do is to grind them up to have small shreddings. In the past I tried a blender, a modified paper shredder, and even built a hand crank shredding machine, which all to some degree work, yet the most reliable thing is still a real electric shredder that I fortunately have as well. So I fed the failed cases, purging blocks and printer poop into the machine and let it chew through the plastic. The ground up material was already mostly fine enough, yet I still sifted and put the parts that were too big back into the shredder. At first I kept the blue and gray shredding separate. I had to learn more than once that dry material is essential to make good filament, so I took all of the material, put it onto a tray and placed it into my drying oven for 3 hours at 60 degrees Celsius. Since I was a bit lazy, I mixed the two separate colors together, hoping that the shredding color would still turn out nice. To get the last bit of moisture out of the material, I poured everything into my vacuum chamber with a bit of desiccant and evacuated the still warm particles. The next day I was finally able to try out how well the Artme3D Mark II handled my shredded 3D printing waste. So I turned the machine on and preheated it to the recommended starting temperature of 180 degrees Celsius. While it heated up, I installed an empty spool of filament on the holder and adjusted the end stops in a way that the filament guide reached both sides of the roll. Then I added some scoops of the shreddings into the hopper. Once everything was hot, I started the extrusion process and was super excited once the first bit of our recycled filament came out of the nozzle. I think you were able to hear my enthusiasm if things start working that I built and where I see the opportunity to learn something new. We have a 3-year-old daughter, and I really hope that she at some point finds the same level of excitement in doing things with her own hands, learning something new and just building stuff. This is one of the reasons why we have been subscribers of KiwiCo ever since she wasn't even a year old. KiwiCo, who sponsored this video, is making awesome hands-on projects for kids all around science, technology, engineering, arts, maths, and then puts them in these crates and delivers them directly to your door every month. KiwiCo has 8 subscription lines for different age groups and topics, seriously starting from toddlers all the way to complex and engaging projects for teenagers. Each box comes with everything you need for the project, so you can do them anytime without needing to worry about that you run out of something. Emmy is always super excited when a new KiwiCo crate arrives. Recently we made bubbly bath balls together. While she was making a fun and exciting mess on her table, I was able to explain to her how citric acid and baking soda, which she knows from making cake, make her bath balls bubble in the water. Every KiwiCo crate comes with step-by-step instructions and a ton of additional info all around the project to dive further into the topic. Building these projects is not only a great way to excite your kids about STEAM topics, but also make a great bonding experience for the whole family and gets them away from Fortnite? Is that still a thing? Well, anyways, if you use the link in the description or use code CNC, you'll get 50% off your first month of any of their subscription lines. Christmas is coming and a KiwiCo subscription is a great holiday gift. So invest in something useful, excite your kids in what you're excited as well, and click the link in the description or use code CNC to get 50% off your first month of KiwiCo. So I let a bit of material extrude out for a little bit until the flow equalized and then started the spooling process. To do that, I first cut off the freshly extruded material right after the nozzle and guided the strand by hand through the sensor arm and towards the feeder until it was pulled in. Then I adjusted the feeder speed so that the sensor arm stayed in more or less the vertical orientation. Once this seemed to be the case, I started the auto pulling process. In this mode, the extruder will go faster if the filament hangs down more, and go slower if it's getting too far up. To start the winding process, I once again cut off the filament where it leaves the guide and threaded the end through a hole at the spool and bent it over so it doesn't get pulled out. I used the first couple of meters to make sure that the filament diameter was close to 1.75 millimeters. Dialing the diameter in is something that needs a bit of experience and skill. The parameters won't be universally usable and will depend on the filament type and even color. Yet Artme provides some good values to start with. So if the diameter, for example, is too big, you can increase the extrusion temperature. If it's too thin, you can reduce it. Yet also the position and strength of the cooling fan, position of the sensor, and also the RPM of the extruder screw can change the result. I regularly measured the diameter of the filament with calipers, which is something that isn't optimal, and once I was happy with it, I just let it run. I filled up the rest of the hopper with the shredded material and could nicely see over the course of 3 hours how the spool slowly filled up with a really nice looking filament. The extruder ran in a different room, and I was always wearing a respirator when checking because extruding so much material is a bit smelly and probably also a smell of the unhealthy kind, but you do you. The winding wasn't perfect, but I mean, what can you expect from a first try and an inexpensive DIY solution? During the process, I could really see how the stir bar feature helped to mix the shredded material so that it was nicely and, more importantly, evenly fed. I hooked up a power meter since people always ask how much energy is used, and I was surprised that it only drew on average around 60 watts, which is far less than a 3D printer and just what an incandescent light bulb needs. I regularly checked the diameter of the extruded filament, which fluctuated plus minus 1/10 of a millimeter around the 1.75 millimeter target. This means at least this batch is not as precise as most commercial filament, but hey, this is a $600 machine and 100% recycled material, and in the end, the proof is in the eating of the pudding, or rather in the printing of the recycled filament. So once most of the shredded 3D prints were eaten up by the extruder, I stopped the process, cut the filament and removed a really beautifully looking roll of filament without any noticeable bumps and inconsistencies. So as I said in the beginning, this material once was the trash and leftover from my soldering tip case production. So what better way to use it than to print more cases with it? I loaded it onto my Bambu Lab A1 Mini and started printing without any special settings. And oh boy, I wasn't disappointed by the results. Mixing up the two colors only led to a bit darker blue color, but the prints looked really pretty. The only way I was really able to tell them apart from new filament was the fact that there sometimes were a bit of color streaks in the material, where more of one or the other color was fed. I also printed this owl as well as a mini Stefan, which both turned out beautiful. And I honestly wasn't even able to see variances in the filament diameter on the print. During the time I've had the Artme3D so far, I extruded 2 more batches of recycled PLA. One was some leftover filament poop shreddings that I had from my last video, which came out really beautiful. Due to the compact design of the Artme extruder, there isn't a lot of material mixing happening in the barrel, which results in this really unique color gradients in the material, and particularly on the prints. The third batch was from some 3-year-old shredded material I still found in my basement, but that also extruded really well. This had a significant portion of black, so it extruded in this really dark gray with a bit of glitter. Filament diameter variation was around plus minus 0.1 millimeters, but the prints didn't show any of that and were honestly really nice. So besides these mini Stefans, I printed more cases from my own recycled filament, which you can find as a limited edition in our shop at cnckitchen.store. At the end of the last batch that I did, I noticed that the extrusion rate significantly dropped. During my first batch, the feeder was set to around 30 revolutions per minute, but during the last hour of extrusion of the last batch, the feeding speed dropped down all the way to around 16 RPM. This could of course be simple due to the material that I ran, but I already suspected that the melt filter caught some stuff and slowly clogged. So I first purged everything that was still in the barrel with some plain PLA pellets and then unscrewed the nozzle holder with the melt filter. At first sight it didn't look too bad, but upon further inspection I was able to see some bigger metal pieces and also a bunch of glitter that accumulated. I had no single clog printing any of the 3 recycled batches, so the filter clearly does its job, but it seems to require a bit of attention from time to time to get the machine running smoothly and efficiently. In summary, I'm super happy with the Artme3D Mark II DIY filament extruder. You really notice that this is not the first generation of this machine and many problems have already been ironed out. You can clearly see David's German engineering background. He did a tremendous job designing the machine and putting the kit together. That's super simple to assemble. Running the machine will require a bit of tinkering, and you can't expect tightly toleranced filament like from machines that cost orders of magnitude more and use virgin materials. But as my tests showed, the material that I made seemed to be perfectly usable for many applications. Yet the machine is definitely not perfect. The wire sensor arm is annoying and sometimes the filament gets stuck to it and then bounces around. Measuring the diameter is not super easy, and of course it would be great to have some kind of an active feedback system. But the amazing thing is that the design, electronics and firmware are all freely available and mostly open source. So if you have any special application or simply want to improve it, you can do that and contribute to the project. I'm quite sure that this is the least expensive yet still really well working solution if you want to get into making your own filament or recycling your old prints. 650 euros is still a lot of money and doesn't include a shredding solution yet. There also aren't that many makers that will make their money back in saved filament. Yet, just like consumer 3D printing, if you see this as a hobby and are happy if you can recycle your old prints, even though it doesn't save you any money, this is probably the best bang for your buck filament maker that you can get at the moment. But please let me know your thoughts in the comments about filament recycling and what you would like me to see doing with this machine in the future. Do you see this as a feasible solution for hobbyists or makerspaces, or would you just rather discard your old prints? Thanks for watching, everyone. I hope you found this video interesting. If you want to support my work, head over to Patreon or become a YouTube member. Also check out the other videos in my library. I hope to see you in the next one. Auf Wiedersehen and goodbye.